Good morning. The first conclusion that I reached is that this presentation should be called susceptibility of buildings and not vulnerability of buildings. But moving on, our idea was really to understand the factors that really improve or that really decrease the behavior of buildings. These are some known data regarding damage caused by fires in the wildland-urban interface, and we really see that we have had significant damage in terms of victims, in terms of burnt houses, and those results, of course, are not always widely known. But we really understand that countries like Australia, United States, where there are frequent forest fires, but also in southern Europe, Portugal, Spain, in Greece, we have had some serious situations. We all know that forest fires really are a problem, and we have several buildings in this wildland urban interface, and we know that there was an increase in these areas leading to the significant increase in the associated disasters. We have some data, for example, the 2003 fire in Mafra and in Monchique Mountains and Silves in 2003, and we know that really there were damages in terms of burnt area, in terms of houses. We did not have access to more data. We don't know if there is information on the burnt buildings, how and why they burned, and that information will certainly be useful. We really did not have the opportunity to research that regarding the national situation. We develop work on the collection of information, a behavior of information, and the ignition mechanism. The idea was to identify the main critical aspects of buildings that had to do with the type of construction, architectural aspects, construction materials used, and really try to understand how certain solutions might be favorable or not, and try to understand in if other countries there are recommendations or standards that could be useful and even adapted to our reality. The research focused on the experience gathered in Spain, Greece, United States, and Australia, namely through reports on fires in the wildland urban interface, which were published namely by laboratories and other journals, scientific journals. Our objective is really to characterize our national situation and analyze, to really try understand traditional construction and light construction and non-traditional types of constructions that are more and more present in our territory. So to characterize really housing in the wildland urban interface, we have an idea of what has been built. I don't know if this information is systematized, it would be useful. And to also analyze the record of damages, something that might be available not to all, but this information might be available and might be useful to interpret all of this data. And our objective is really to try and develop some recommendations to reduce the susceptibility of buildings, and also when it comes to systems of construction, using innovative techniques or innovative materials. to apply to those areas, to have a critical approach, to have rules, really. It's interesting to see then what it happens in practice after you apply the rules. We all know the sequence of factors that really lead to a disaster in the wildland-urban interface. It has to do with favorable conditions, conditions which favor a forest fire. If there is ignition, the behavior of the fire can be extreme depending on the conditions. If there are buildings exposed to the condition, if they are not very resistant to ignition, those buildings may catch fire. And if we can suppress the fire, and if the measures are not effective in terms of protection against fire, we may have the destruction of buildings. We have already addressed the issue of the mechanisms of attacks and destruction of buildings in the interface, radiation, convection, and transport of incandescent particles, and the way in which one or other is determinant has to do with the building and the surrounding area. The building itself may contribute to ignition and the propagation of the fire, depending on the materials. And there is also the issue of fire penetration that may lead to the ignition of the interior of the building. And in our traditional construction, it is something that is considered very critical. And so the idea was to try and understand the characteristics in terms of materials, in terms of adjacent areas. And in the first stage, we collected information after fires, especially in the United States and Australia, where there is a lot of information available. And the main differences in terms of these two countries is that in the United States and Australia, construction uses combustible materials, wood or other materials. In Mediterranean areas, we have materials which are not combustible outside buildings, what we in civil engineering call the outside of the building. So the skin really of the building, the walls, the coating. Considering the conditions and the characteristics of buildings, and given that in the United States and Australia they use combustible materials, one of the issues is really proximity between buildings, and this has to do with the concentration of fuel. The building itself contributes to the spread of the fire from building to building. And so proximity is one of the critical factors. In terms of non-combustible materials, we see that openings, cracks, and weaknesses are really what is relevant. They allow the entrance of fire. And where there are combustible materials, in here, it is considered, based on the studies that have been conducted, that greater construction density really minimizes, or at least does not contribute to increased risk, because where we have houses, we don't have trees, and so the amount of fuel is lower when compared to combustible buildings. The concerns that have been highlighted by these reports when it comes to combustible materials has to do with protection measures that really prevent the ignition of outer materials, so avoid contact with embers, with firebrands. When it comes to non-combustible materials used on the skin of buildings, the concern has to do with openings, with cracks, with weaknesses of the building that allow the fire to come in and the ignition inside the house. Considering the damage reports in the accident reports which were analyzed, we identified certain critical aspects that make really buildings more susceptible to fire. When it comes, for example, to houses or exterior pavement on bollards, on not stilts to say, but when we have this type of construction we see here in the picture, it is more really susceptible. We see that even after the fire, there is the ignition of the building has to do with really those incandescent particles near those combustible materials. It is more critical when it comes to really combustible tiles or slabs. When it comes to ventilation openings, they are really one of the critical points of entrance. And even in situations where measures are adopted to prevent the entrance of birds, the mesh that is used, of course, to prevent this, the grid that is used does not prevent the entrance of these particles, and so leads to the ignition inside the house. Windows are a problem, in fact, very critical. If they are opened, of course, they allow for the entrance of these particles and radiation or even flames. If they are closed, the glass may also crack, break, and particles may entrance. When it comes to shutters or other devices to provide protection, if they are combustible, they are also a risk factor. So it is considered favorable to use fire-resistant shutters closed during the fire, or metal mosquito nets that also seem to have protected houses during forest fires. Exterior doors. And when we talk about window frames, this also apply the entire frame. If there are recesses where particles may accumulate, this should also be prevented. And we also identified certain situations where the use of fire shields also seems to limit the spread of the fire and ignition inside the house. And roofing materials are important. They sometimes allow the accumulation of dead vegetation. Tiles sometimes are deteriorated, they have a complex form, they have recesses, or there are other parts in the eaves that stick out, and all of this can really lead to the susceptibility of buildings. If fire comes into contact with the roofing materials, in attics, we have the accumulation of combustible materials, inks, mattresses, furniture. So we have here really a thermal really load, and even the insulating materials, everything that is usually in this roofing is something that can contribute. The roof, when it's damaged, the tiles, when they are damaged, when they are broken tiles and allow the entrance of particles, eaves, depending on the materials used, can also be critical. And when there is really the accumulation of other materials, it can lead to the ignition some of the materials, and of course chimneys, gutters, and sometimes really the design of chimneys is not good, and it allows the entrance of particles, and when there is a lack of a metal net. Another aspect which was identified was susceptibility associated to decks or balconies made out of wood. It can be wood, untreated wood, or plastic. It can be composite plastic. They're very used, for example, in the United States instead of plastic, instead of wood, in fact, and may have really a different behavior from what we would expect. Garden furniture and surrounding, of course, vegetation that can then spread to the house. This is essential in terms of the facades, in terms of the skin of the building, and the combustible materials that might be used. In terms of sheds and garages, they're also quite vulnerable, usually because they are very sensitive, maybe not all of so vulnerable and as this one, but the issue of propagation to the inside of sheds or others when the facade is very sensitive, and this was identified as one of the critical problems. Another aspect has to do with wood fences. There are reports that show that wooden fences initially may be a barrier against radiation towards the facade, but if they start burning, they will contribute to the propagation of the fire. Some reports mention that if these fences are not combustible, or if they are combustible, but if they are wet, they may act as a barrier against fire and then prevent the propagation. Other situations, containment walls made out of combustible materials that may have also contributed to the propagation of the fire. And so the use of non-combustible materials in walls, in tracks, roads, and coating is one of the things that should be taken into account. Vegetation, we know that it can be a problem. The reports also mentioned, although there is a likelihood of destruction of buildings that are surrounded by vegetation, if the plants are well selected and positioned and maintained, they may reduce the exposure of buildings to direct radiation. So it's something that should be considered. In terms of the national situation, what we found in terms of recommendations regarding the protection of buildings and surrounding areas has to do with maintaining the surrounding areas, to remove vegetation, dead vegetation, and what we found has to do really with preserving a clean area around the building without accumulation of firewood. And of course, there is also the need to maintain the roofing and the eaves completely cleaned without any pine needles or leaves. And of course, also a retention net in the chimney of the house. And there might be municipalities where other recommendations may have been given, but I believe that usually there aren't very definitive recommendations. It's just about really maintaining the area cleaned and some certain actions that can really be performed by people. It's interesting to see that these minimum distances vary a lot from country to country. We found recommendations from 9 to 100 meters depending on the risk of forest fire, so the weather, the surrounding area, and we also found some specific rules that have to do with construction solutions that has to do precisely with the degree of fire risk in the areas which were considered. And what about Portugal in terms of legislation? Portuguese legislation on prevention strategies is not specific regarding construction solutions for buildings. National regulation focuses on the propagation inside buildings, and I think that the concern has to do with urban fires. And so the propagation from the inside to the outside of the building and not so much from outside to inside. But I wasn't involved in the drafting of the regulations, just reading it, the information that I drew from reading it. More specifically, the decree law that is mentioned here, 220 from 2008, has provisions which can be applied to all buildings. It has to do with the type of use in the risk category. Housing is type 1. Single family houses, which are most of the building with which we are concerned, are in the first risk category. And recommendations, the present recommendations for these buildings are not very serious or very strict. The demands have to do with the performance of construction materials in terms of reaction to fire and resistance to fire, and which usually they have to do with the geometry of buildings, the facade of buildings, and how they relate to other buildings. So there is a relationship between geometry and the characteristics that are demanding of materials, but it does not have to do with risk areas in terms of forest fires. But as I said, the concern regarding this decree law was not that. There are a few chapters that have to do with that, limiting propagation of fire outside. But usually the propagation from building to building or from one floor to another is what this addresses. There are a few recommendations regarding gable walls, regarding non-tradition outside walls. And there are a few recommendations regarding the characteristics of materials in terms of resistance, in terms of reaction to fire, depending on the level of exposure. Here we have it for outer coating, for facades, frames, shutters. fire resistance, minimum fire resistance in terms of structural elements of buildings, and when it comes precisely to single-family houses. Gable walls, a few recommendations, fire reaction in terms of the coating of decks, and there are some requirements in terms of fire reaction, but general recommendations that do not account for location. It is interesting to see that in New Zealand there is a standard for the construction of building in areas with a potential risk of forest fires, which really establishes a determined area, determined zone in terms of the risk of forest fire. It has to do with the type of vegetation around the building. It has to do with the proximity. It has to do with really the slope of the terrain and the local atmospheric conditions, and then it gives some recommendation and solutions in terms of construction. These specifications really do not prevent the use of certain materials, but they recommend certain certain things that, for example, if you use combustible materials, it should be high density wood. If you have combustible decks, for example, or if you have outside vegetation close, you should have certain nets protecting. So very specific recommendations. It is really possible to really understand the factors which are unfavorable in terms of fire behavior. In terms of really construction details, we know that recesses, frames, glass. We have mentioned these aspects. We also know the factors which are favorable in terms of fire behavior in buildings. There is information which has been systematized regarding this. Regarding some of the materials that we use, we know that there can be added risk. In terms of facade coating, it is frequent to use attics or claddings of combustible materials. When it comes to insulation, when it comes to decorative coating, combustible coating, thermal insulation, and really elements for which there aren't recommendations regarding their use. When it comes to roofing, using organic material or even on decks, thermal insulation inside covers roofing against infiltration and combustible thermal insulation. In frames, sometimes plastic used for shutters, but also thermal insulation in shutters and in shutter frames. So there are a lot of materials that should be considered and that represent an added risk. Here we are, concluding. We really understand that if really the skin of the building is combustible, we can have ignition from the outside to the inside. If it's not combustible, the ignition of the building has to do with the penetration of the fire through cracks or weaknesses. But really the vulnerability of buildings can be reduced using favorable construction measures. But there are the measures that are easier to implement, that do not have to do with personal choices, that have to do with protecting, opening and selecting materials that have a proper behavior or proper treatment. It was mentioned treated wood. When we buy treated wood, generally we are talking about wood protected against biological deterioration, which is something that usually concerns people. Protection against fire is something else. There are some materials and some products, certain protection products that can really be beneficial in terms of durability, but also in terms of fire behavior. And so here we have this issue that we try to master, the factors that contribute to susceptibility of buildings in the wildland urban interface, the behavior of the materials which are used. But there are, of course, new materials or untested materials that should be subjected to tests, and really to try and systematize all of this information regarding the housing buildings that we have. So the issue is, can we implement recommendations regarding construction solutions for risk areas? Thank you.